What is matter? Now, matter is a substance which can be felt by our five sense organs, that is, which we can see, which we can smell, which we can feel by touching, and so on. But if suppose I give you a piece of chalk, you can touch it, you can feel it, so it is a matter. Now in this chapter we have to study that is matter pure. Suppose we go and buy milk, common salt. Then when you bring it and you ask any layman person that what is NaCl pure? Then he will answer you, yes, it is pure. Milk pure. Then ghee pure. But according to chemistry, they are not pure substance. Pure substance are elements, that is, which are made up of single kind of atom. Now, suppose we take the example of milk. Milk is the combination of water, fat, protein. Now, it is made up of three things. So, according to chemistry, it is not pure. It is made up of three substances. Similarly, suppose you have sugar. According to us, it is pure, but it is not a pure substance. It is a compound. For example, it is made up of 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. NaCl. NaCl again, it is compound. It is not an element. It is made up of two types of atoms, sodium atom and chlorine atom. But they combine. They combine the two ions, that is Na plus and Cl minus, to form sodium chloride. So it is a compound, ionic compound. Now it means when the substances are formed by combination of many atoms, then they form compound, or you can say mixture. What is mixture? Mixture are the component of two or more substance. Components of so mixture are made up of two or more components. Now we can take the example. Suppose at home we prepare now at home when you prepare this board, where it is the board. When we prepare sugar solution, means in water you add sugar and stir it. After some times you see that the particles of the sugar are not seen in the sugar solution. So where does this particle goes? These sugar particles, they go into the intermolecular space. These experiments or activities you can do at home also. You can add salt and water. Again, you can see that salt gets dispersed in water. You cannot see the salt particles after dissolving it. Second activity, if you add mud in water, mud in water, and you stir it. So when you will stir this, you will see that sometimes it will look like that it has dissolved, but if you keep it for some time, then this mud will settle down. Then this mud will settle down and water will be at the top and the mud will be at the bottom. So this kind of mixture is called suspension. And when the particles get dissolved, they are called solution. Now you can also take the third activity, that is if we take milk and water or blood and water or ink or water, then you will see that the milk gets completely miscible in water. Similarly, blood will get miscible. But through this mixture, we will not able to see. We will not be able to see. So this kind of mixture is called colloids. This kind of mixtures, they are called colloids. So one activity is given in your book, that in that four different groups are formed, in which one group gets sugar plus water, second group mud plus water, third group is milk plus water, and then question was asked ki why this difference is there. So now mixture is of two types. Mixture, it is of two types. Where is the pen? Now I have given you an example of sugar. Now in sugar, not dragging. Yes. Now sugar in water, it forms solution. This mouse is not working. Okay, let it be. Now mixture is of two types. Wait a minute, wait a minute. I'm continuing. Wait a minute. Wait. Wait, we are clearing the technical problem.
Yes.
Now, mixture is of two types: homogeneous mixture Homogeneous mixture are the mixtures in which the composition remains same throughout. What does it mean? It means that if we take the mixture from top, bottom or middle, if it stays as sweet, then it will be sweet all over the mixture. Whereas in the case of heterogeneous mixture, heterogeneous mixture, the composition is not same throughout. Composition remains same. Where here composition is not same, composition is not same. Now the homogeneous mixtures, under it we get the first, that is solution. So homogeneous mixtures are called solution. Now solution is made up of two components, solute and solvent. Now what is solute? Solute is the substance which is dissolved in the solvent. That is the more amount. Now in this class we will study, then you will presume that water is the solvent and sugar is the solute. But it is not necessary. Sometimes solid may also be solute. You can take the example, that is alloy. Now what is alloy? Alloy is the homogeneous mixture of two or more metals. You can take the example of alloy, copper, zinc. This is called brass. At home we call it as petal. Second example of alloy is copper and tin. It is called bronze. And the most common example, that is the jewelries which your mother or your sister wears, it is also an alloy of gold and sometimes silver, sometimes copper. Now properties of solution. Properties of solution. Now you can imagine, if you pass sugar solution through a filter paper, it will pass easily. So it can cross the filter paper. Now if we want to separate the two components of the solution, that can be separated by heating. If we start evaporating, then sugar will be present at the bottom and water will evaporate, and that can be collected by condensing it. Second example, that is which you already in day-to-day life, every day you use, that is cold drink. Cold drink is the cold drink, mixture of water and carbon dioxide. So water is solvent and carbon dioxide is solute. Now it is very difficult to dissolve any gas. It is very difficult to dissolve any gas in water. So when we apply pressure, then the carbon dioxide gas dissolved in water. So that mixture is called aerated ring. It is mixture of water and carbon dioxide is called aerated ring. Next, the air in which we remains in the atmosphere, it is a mixture of many gases. For example, air contains oxygen 21%, then nitrogen 78%, and rest percentages of inert gases. And some impurities are also present in the atmosphere. One more solution is there, that is tincture of iodine. One more solution is there, that is tincture of iodine. Now what is tincture of iodine? Tincture of iodine is a solution of tincture of iodine. From all these topic, question may be asked, so you can note it down. Suppose it is that what is tincture of iodine? So in tincture of iodine is, that is iodine dissolved in alcohol. It means iodine is the solute and alcohol is the solvent. So next properties, under first property I told you that they will cross through the filter paper. The particles is so small that you cannot see by your naked eyes. And next here, now how much amount of the solute is dissolved, how much amount of the solute is dissolved, that is called concentration. So I will tell you how to find out concentration. And one more property is that because of very small size, they do not scatter a beam of light passing through the solution. So the path of the light do not get segmented. Through the aqueous, the homogeneous solution is transparent. Through it where we can see it. All this you can study by performing, by dissolving sugar in water and see if it is a glass made up of glass, then only you can see. You cannot see through the steel glass. Now, next is concentration. How to find out concentration? Before calculating concentration, there is also one more term called solubility. Solubility. Now, solubility is amount of substance dissolved per 100 grams of solvent is called solubility. Now concentration, suppose I ask you, okay, what will be the concentration of 50 grams of sugar dissolved in 250 ml of water. So for it, you can write down the formula also, that is weight of solute divided by weight of solution. Solution, all of you know, it is the weight of solute plus weight of solvent into 100. It means that here 50 grams of solute dissolved in 250 grams of solvent. So we will add it 50 plus 250 into 100. So you will get 50 divided by 300 into 100. So 0 0 cancel, and you will get 3 1 the 3, then remains 2, 20, 3 6 ja 18, 6 6, and so on. So you can likewise you can find out the okay. Last topic means concentration. Concentration means how much amount of the substance is dissolved in the solvent. Now, when we'll dissolve this solute, that will go into the same solvent, and it will form solution. To find out concentration, we always find out concentration in percentage. Just like you calculate the percentage of your marks, that how much marks you got out of and into 100. Similarly, uh, yes, you have Bharti Kushwaha, you asked that weight or mass. See, in here chemistry, we can call weight or mass both are same, but in physics it is different. In physics, the force by which it is attracted by earth, then it is called weight. But here you can call it given mass, some books it is given mass. And when you go to the market, you ask the shopkeeper, give me the mass. You said how much that you always ask in kilograms or grams only. Similarly, here also in chemistry there is no problem. You can use weight or mass. Both are same. Now, so weight of solute divided by weight of solute plus solvent into 100. I have taken one example. You can take some more examples. It will be given to you in your book. I will see. Example 2.1. Now here it is given 40 grams of example 2.1, that is 40 grams of NaCl and 320 grams of water. Now calculate the concentration in terms of mass. Now see here, 40 grams is solute, weight of solute, divided by 40 grams of solute plus 320 grams of solvent into 100. You can calculate. Now, solutions are of three types. Now, the solubility, one term I left, that is 100 grams of solvent at constant temperature. At constant temperature. Now, when we start stirring sugar in water, You suppose I give you 5 grams of sugar and 50 ml of water, and I ask you to prepare solution. What you will do, you should not add directly into it, because you do not know that how much amount of the sugar will be dissolved in the 50 ml of water. So you start adding, that is 1 gram first, you stir it, and again second gram, third gram, likewise it will go on. So the solution in which the solubility will go on, that solution is called unsaturated solution. Those solution in which more amount of the solute can be dissolved is called unsaturated solution. And once the solubility completes, means small amount of the sugar is present in the beaker, then it is called saturated solution. Now if suppose you start heating the saturated solution and you add 1 more gram of sugar into it, then it will form super saturated solution. So on the basis of three types of solution we have studied. Next is heterogeneous solution. कहाँ गए गणेश? Yes. Now heterogeneous solution, they are of two types. Now heterogeneous solution, if first is suspension. If you add mud or chalk powder in water, you stir it. You will see that the solution, when kept for some time, will separate. Means the mud or the chalk powder will settle down and the water will come up. So such a kind of solution, a mixture, not solution, mixture, which gets separated out is called suspension. And the best example I've taken of mud and water. The properties of suspension. Suspension is a heterogeneous mixture. The particle size is so big that we can see it by our naked eyes. Next property is the suspension can scatter the beam of light through which it is passed. Means if you bring a torch in front of the suspension, then you can see that the beam of light gets scattered, means it spreads out. And last, that is, the mixture can be separated by physical methods like filtration. If you add the mud into water, keep it for some times, mud will settle down, and first you decant it on the filter paper, the mud will be at the top and the pure water will come out as filtrate. Second type of heterogeneous mixture is colloids. Now colloids are the heterogeneous mixture of two components. But you can take the example of milk. Now if you add milk in water, after some times you will see that the milk gets completely dispersed in water. And when we see through our naked eyes, we cannot see. Maybe the solution is opaque. Yeah? But it has two special properties. Number one, the particle size is in between the solution and suspension. Number two, they remains in continuous motion. The particles in colloids moves continuously. As a result, they remain stable. They never separates out, just like solution. That is called Brownian movement. In short, you can say that Brownian movement is the Brownian movement. Brownian movement is the zigzag movement of the particles. Means these particles, they are in continuous motion, they strike to one another and their path deviates, so they remain stable. Means they, just like solution, you cannot separate the solute and solvent in the case of colloids. This is the most important property of colloids. It is shown by colloids only. Next is Tyndall effect. Now, Tyndall effect is when we pass a beam of light through colloidal solution, they scatter and they form a cone. And this you cannot see at home because it is seen perpendicular from the top, then it is seen that it's scattered. But the best example at home you can see, if suppose you have small holes in your windows or doors, and when the sunlight is entering into it, you see that the light scatters like this, and many dust particles are present in the way. So when we see that our house is very clean, we feel very happy that complete cleaning has been done. But if you see through a beam of light, many dust particles are present in it. So the two important properties of the colloids are Brownian movement and Tyndall effect. Now again, properties: if you pass through filter paper, both the particles passes through the filter paper, means the size of the particle is so small that it crosses the filter paper. So for today we have completed what are the type of mixtures and what are the type of mixture. If you want to ask any question, you can write down in chat box so that I can answer if anybody has got any problem. Hmm. I will leave you, don't worry. Hmm. Robin, Sony, I will leave you, don't worry. All of you have understood? Have you understood? Homogeneous mixtures are those mixtures in which the solute and solvent particles are mixed so that you cannot separate out. They are transparent, their particle size is very small. That is homogeneous mixture, and the best example is the जो शरबत हम घर में बनाते हैं, वो उसका सबसे अच्छा एग्जाम्पल है. आप घर में बनाइए और देखिए और पता चल जाएगा what is homogeneous mixture. Mixture are of two types: homogeneous mixture and heterogeneous mixture. Homogeneous mixtures are called solution. Heterogeneous mixtures are colloids and suspension. Any question? What, you did not got anything? Robin, Sony, what do you want to ask? So that is your problem, not mine. Colloids are the heterogeneous mixture in which, Kartik Kushwa, it is for you. Colloids are the heterogeneous mixture in which the particles are so intermingled that you cannot separate out, but they are opaque. You cannot see through it. For example, milk in water. Milk, if you see milk, put 5 grams of milk into 100 ml of water and see what happens. After sometimes it disperses like anything and you cannot see through it. That is colloids. So what you were doing when I was explaining? Huh? Now homogeneous mixture, if you pass through filter paper, it will pass through it. It can be seen through our naked eyes. And thirdly, it passes the filter paper. Madan Singh, understood? Any more questions? Today I will send this video in the group also, don't worry. Whatever I have taught today, that will I will send you so that you can prepare the notes. The first chapter is related. Now I am going to stop.